Hello everyone. Today I'm going to give you a brief introduction about how to do two-way ANOVA using Minitab software. Initially, I would like to share my screen with you, and here is the data set that I'm going to do the two-way ANOVA. Initially, I have to say when to use two-way ANOVA. Actually, imagine there is a condition like there are two categorical independent variables and one dependent numerical variables. The important thing is there should be a one numerical dependent variable. It means there should be a meaningful numerical dependent variable, and there are several assumptions to satisfy to conduct the two-way ANOVA, and especially actually almost all the assumptions will be satisfied if the dependent variable is normally distributed. But we can't guarantee every time. We can't guarantee that they are but we have to just assume. Actually, the requirement is the dependent variable should be independent and identical distributed. Also, that is a major requirement of the data set. And then the other requirements are coming with the residuals. It means the error term must be uh, normally distributed with constant mean and with constant mean and with constant variance and zero mean. And that is the those are the things that we have to consider when we are doing two-way ANOVA. Here I will, but here I will show you how to do the steps to do the two-way ANOVA. And at the end of the session, I will give you the requirements and all. And here we have to look at, initially I have said that we have to have two factors, and we have to have one dependent numerical variable. The factor should have more. The factor should have few category levels, and here we can see this is we have three treatments. It means treatment have three levels, and also we have another factor called time. Okay, then the data is collected from initial values, and then first week, and then second week. Data is collected in that way. And the next thing is, then we can't do the two ANOVA if the data set is in that way. We have to structure the data into a proper manner to do the two ANOVA. Here it means we have two factors, and we have to arrange a two factor initially, and I will do it in here. I just type here treatment, then here I will type time it mean week. Then what then the requirement sheet is we have pH and moisture content, but we don't need to be worried about if there are two dependent variables, because yeah, we have to consider only one at a time. Again, initially I'm going to consider pH, and here I will put pH. I will say the reason to put here in pH, and then secondary value, sorry, TB value, then TC value. And here in the case of treatment, this is TA, and this is 3A, and this is going to be TB, and this is going to be TC. And here, because I have used initially, just I will just put I. Then all the things are initial week data, because I know what is happened here, and then I will copy this. Then I type here 1, because to represent the first week, or else I can write down here first week, or it is up to you. This is just a representation. Then again I will copy this to the all over the, because this is here the first week data I'm going to copy to here. Then again I will copy this here again, because I have two second week data as well. There may be a situation more than those amount of data, but initially I'm going to just give you a brief idea about how to do two-way ANOVA. This is the very much important thing, because the structure in data is the very important thing in the case of research data analysis. And here also I will use moisture as well as in here, because then it will be really easy. And if not, I have to copy paste this again and again. Now I am preparing my data set to do the two-way ANOVA. Then here I have again moisture content of T press tweak TA. I will copy paste here them. Then I have the moisture content of TB at press tweak. I will copy paste them in here. Again, I have the moisture content of TC, and I will copy paste them here. Then after that I have to think about the second data here, the moisture content of TA at second week, and I will copy paste them here. Then again we have to have the moisture content of TB here, and I will copy paste them here. Then we have the moisture content of TC at second week. We have to consider about that as well, and then I will paste them here. And then I have allocated a location. I have allocated a row here. I have put a space here. The reason why, after doing two-way ANOVA, we can get only the interaction effect between those items, but we don't know what happens here. We can't see where the difference. It means which where the real difference occurred. We have to make sure that where or how it occurs, and with with what treatment that difference occurs, and which treatment has a higher pH value, which treatment has a lower pH value, also which combination has a higher pH value, which combination has a lower pH value. It means there might be a situation like TA at initial it can be highest pH value. On the other hand, TA plus it can be the lowest one, because there may be a situation like combination effects. And uh, uh, to identify those things, we are doing the two-way ANOVA. Then the other thing is we have to make a combination. I will put here T and TI just to represent a treatment and time, just to represent treatment and time, TRAT, treat time. Then I will just copy here, and then I copy paste here, and I will put this sign, and then I will copy it again here. I will say you why I am doing this. This is okay. Then I just type T. Sorry, I will type capital T, then capital T. Then I will type B here, and you will see. Then I will copy this one and paste it to here. I will copy it again and paste it to here, and then again I yes. Then you can see the Microsoft Word, Microsoft Excel automatically create the combination if you done it few times. Sometimes it may be occur within one copy and paste, but here I have to do it few times, and then the combination will be automatically generated. And why I have done this, I have said that we have to make sure, we have to see the which combination has the highest pH content or lowest pH content, or like that thing. We have to think like that. And then we are created our now we are structured our data set. Okay, you can see that clearly here. You can see here the treatment TA, TC, and also initial time we can see per streak data. there is the combination. You can see TAI, and these are the replications, and you can see there are three replications of TAI, and those now we are created our data set. We have already structured the data set uh, to do the two-way ANOVA. Then what we have to do is we have to go to uh, Minitab software, and here I'm using Minitab 17, but the procedure with Minitab 19 and Minitab 21, all the things are extremely same. Only the thing is output will be little bit different, or the output mean the color of the output and all the things are a little bit different, and there are some additional features with Minitab 19 and 21, but the event connecting to ANOVA, there is there is nothing much different between those Minitab levels, because the 2 ANOVA is 2 ANOVA, and it is similar for all most of the softwares. But we have to consider something. We got with our software, it gives some different output, and also with SPSS it will be give little bit different output, and also with Minitab it will give a little bit different output. With respect to the software, the some few things with the output will be determined, but the p-values, mean values, standard deviation, errors like things will never be changed. Only the structure of the output will be changed with the software. Now the software is okay. And then what I have to do is there are two ways. One way is I can just select all and copy them, and then I can paste them here. Okay, now I have done the data set. I have included the data set into the Minitab software, and now what I have to do is I have to go to stat. Okay, then the data set is full structured data set. We are using a full factorial design here. You can see full factorial design mean we didn't omit any, so we didn't omit any levels. It means we can see it with TA we have first week, second week, initial date, and with TB the same type of data is occurred, and with TC as well. On the other hand, with time also the same. It means all the combination is included in here. Therefore, we can do the full factorial analysis here. And then to do the full factorial analysis, the easiest way is we have to go to uh, ANOVA, then we have to go to balance ANOVA, then it will give output like this, and we have to put paste for the numerical variable here. Then we have then when we are going to model, it will show this type of structure. Then we have to insert treatment, and we have to use this sign. Okay, you can see it clearly using shift and upward line. You can put in here. Then we have to put time here. I will do it again. Treatment upward slash then time. Okay, here the two factors, the two variables that we are going to do the two ANOVA. Now we can, there are several options, but I don't need to go there because we don't have any random factors as well as also if we have to, we can see residual plots if we are required, but I will just show you these things just for clarification. It is not must. Then these are result if you are required, but those things are not highly required. We cut only these two. Then we have to click OK, and then it will give an output like this. This is a, you can see residual and observation node. Okay, this is a residual versus plot residual versus fitted line like this. Then here we can see if a scatter plot is like this, then there are some it mean there is some sort of a variation with the data, and there is thing within here, and then we can see the histogram source. Well, actually it is almost a normally distributed data set, normally distributed error. Okay, residual. Okay, I have said you there are three major requirements in the ANOVA and residual should be normally distributed, and you can see it clear also in the previous one. Residual was a fitter line, but we can see some sort of a constant variance. It means there is not a exact pattern here. And then Peter tell you, but there is some pattern, but we are anyway we are going to do, if there's not a pattern, then it those points will located in here. And then also normality, then if the data is exactly on this line, the data set will be exactly normally distributed, but there are some limitations, but those things are not extremely higher, because therefore we can use this data set to do the actually ANOVA test. Then then we have to go to the results, and we are, you can see here, there will be a ANOVA. Since we are using two ANOVA, there will be the two factors, and here will be no, there will be the dependent or else numerical variable, and here will be the levels of the factors, and here will be the levels of time, levels of treatment, and those things as an. And here the here the output, and we can see the treatment. Single effect of treatment is significant, single effect of time is significant, but the interaction effect is not significant. It means there is not a combination effect between those two, but uh, even though there is not a combination effect, we have to make sure that which combination has a significantly higher pH value, or which combination has significantly lowest. And also you can see the R sky as well as just R sky is very more than 99%. Therefore, this is a this is we can see a very good significant model here. And then what we have to do is uh, we have to go. Now we have to deal with one way. It means why we have actually, in the case of two-way, three-way, four-way, any type of ANOVA, if there are more than one factor, one variable with more than two levels, so basically with two-way, if there are two factors, if there are only two levels is enough for each variable, because there will be ultimately there will be four variables in the combination. It means in the combination here, since there are three by three by three levels, there will be nine major levels in the treatment time combination. And here now, after doing this two-way ANOVA, we have to go to again stat, then to ANOVA, then one-way ANOVA. Then after that we have to look at here, and we have to do select pH, and then we have to look at treatment time combination. Then we have to go to options, and here we are just going to two-sided test, because we are just dealing with we are just looking at whether it is equal or not. If it is one-sided, lower bound or upper bound we can go with, but here we are going to do this with two-sided way. And then it is okay. Then here the comparison, I am going to use two key tests, and here the interval plots of also different means I will show you, but it is not necessary to use. This one must be used because to see the grouping information. And here this is a four stroke analysis, and this will give you the grouping information about data. I will show you with with the output. And then there are graphs. Actually we have already used, so see this graph will be never be changed, because the dependent variable is same. It is pH, and there are these things. If you are really born, you can go with this, and we don't need here this much. And then results, and here then after that we have to do storage. We can store bits, where bits mean the value that expected to come with the model, and residuals are the the difference between fit value and observations. And then okay, I'm not going to storage. If we put here, if we tick there, then there will be storage in those columns. Then I will put here. Okay, then here actually I have done a one-way ANOVA, because in the combination there is only one variable, treatment. Every time when we are dealing with two-way, three-way, four-way, any sort of ANOVA, more than two levels, more than two variables, then when it comes to combination level, there is only one variable. Then we have to do one-way ANOVA after two-way ANOVA or a three-way ANOVA or a four-way ANOVA. We have to do this one-way ANOVA today to get a better idea about the data. Then I will click OK. Then since I need to see the interval plot, then this will show an interval plot with like that way, and this is not much sorry, this is not much required for us. And then to key simultaneous data, this is also not much required for us. What we need is we have to go to this output, and all the relevant instruction will be included in here. Here, the one way ANOVA, we can see the treatment and treatment time combination, and there is a clearly what is null hypothesis and what is alternative hypothesis mentioned clearly here. And here the here what here the levels of factors, and then the analysis of variance, error, and treatment time. Here what we are required is p-value. Generally, when the p-value is greater than 0.0, lower than 0.05, we have enough evidence to accept the null hypothesis, reject the null hypothesis. It means we can accept the alternative hypothesis. It means at least one mean is different. It means the data is significant. That's some sort of significant difference between the data. Then you can see the data is model is very good fit with the data. Then here the important thing is here we can see the mean value and the standard deviation, and here the confidence interval, and we can use this to do the to make our tables and other to do graphs and all. We can use this data, and I will show you one output with this. And here uh, then here the one of the important thing is here, because the two result how to interpret the two key results of two key tests, and here it is give us because all the information are included in with the data set very well. And here what is we can see TCI, it means initial week. TC has the highest pH value, but it is not significant. But there is not a significant difference between TC at first week and TC at second week. So therefore, there we can see clearly there is not a significant difference between the pH value of TCs at different weeks. Also you can see with the TA the initial value is higher, and we can see that. And here what we have to look at is this letter, and if if the letter is if there is at least one letter is common, then there is not a significant difference between those letters. We can see A, it means there is not a significant difference between these three values. And then there we can see B, there are four B's, and there is not a significant difference between these four. Then there are these four. C is common, since because of that there is not a significant difference between these all. So if at least one letter is common, then there is not a significant difference. Then on the other hand, we can see there is B and C. Therefore, TAI is significantly different from TB and second A. Actually, TB at second A is significantly lower than the TAI. Also, on the other hand, you can say B and these things are all of these three are significantly higher than TI, and that is the way to interpret this data. And then we have to do something with this data. It means okay, I will just show you how to deal with that. And then um, I will open my Microsoft Word, and here I will split my screen because it will be very easy. uh, what I need here is I need to insert a table. uh, I need to insert a table with 4. Okay, I will initially use 4 by 3, sorry, 4 by 4 1, because, and here I will put I, just 1 second. These are 4 peaks, and actually it is better to use another one row above. I will show you why I'm using this, and then here I will put T A, here T B, here T C, here T C. Then I will just put one variable here, T A I, that one. T A I is that, and then what is that? 2, sorry, 2.47. We have to use plus or minus sign. I will go insert and symbols and symbol, and there is I need to go more symbols. You have to look at plus or minus sign. Here there will be a plus or minus sign. I thought that it will be in here, but we have to go scroll down. Scroll. I'm searching still. Okay, there is plus or minus sign, and you can see it is added to here. And then what I have to do is, and here the standard deviation, which is 0.01, 0.01. For better, I will go shift, and here then where we have to look at where TAI is. What is the letter relevant to TAI? We can see it is B. I will put here B. And then why I have kept here, because actually we can type here week. It is totally up to dependent, totally up to you. You can complete the data set in that way. Then you have to write down here at if you have if you copy and paste this here, then it will give a good information about, because mean that do not share letter significant difference. And here the p-value is we are looking at p-value is lower than 0.05. Value that do not share letter significant difference, if the p-value is lower than 0.05, and you can see those things very clearly here. And then for the best practice, and you can arrange a table according to you. And then I will show you another one important thing here. Few important things to be considered with this. First thing is okay. Well, analysis of variance, and it use mean. Need at least 2 replications. Variance with mean will be considered for analysis. Why we are required to at least 2 replications? Because we have to consider variance. Then the one way ANOVA, there are one way. There should be one independent variable with more than 2 levels. More than 2 levels. If there is at least 2 level, only 2 level, we have to do this with t-test and certain slide thing. And independent variable should be a categorical, and dependent variable must numerical with independent and identical distribution. Then the two-way ANOVA. What is two-way ANOVA? Actually, in two-way ANOVA mean there are two factors. That is the difference between 1A and 2. But here we are considering the interaction if it is and all between combination between those factors. We are considering interaction effects. That's what we have done with here. And I describe these things with you initially, and here I will show you another data set. This is also a structured data, but we can see there is not just three level. There can be several four levels, and there are also date can be there is yes, three, four, five. You can see there are several levels, but no matter what we there when considering the combination there will be some levels, but there is only one variable with considering the combination. What we have to do is when you're doing the two ANOVA, finally I'm going to say we need two factors. It means two category of variables and one dependent variable. It should be a numerical one. It is better if it is normally distributed, but the requirement is it should be independent and identically distributed. But the error term should be normally distributed. I have shown you how to see that, and then after doing the two-way after looking at the interaction effects, then we have to go to combination, and with the combination we can do the one-way That's all. Thank you for watching my video. I think this will be better for your education purposes, and thank you.